True language is doing something.
Did it load your U-grade? Use recording.
Is Drew Langer a good influence?
I don't know.
I don't know. Pretty bad.
Professor Schmatz was getting another two.
Yeah, you see this.
Oh.
Yeah, well, we just facing that video.
Peter, you're one dirty dog.
So I gave you guys a new factoring sheet. You probably do have one, but I just made copies for another one. So today, what we are going to do is learn how to simplify rational expressions. And to do that, you have to know how to factor. And the types of factoring that you're going to have to know today, if we look at this, the types of factoring you're going to have to know are trinomials, and there are going to be a couple of problems where there's a number in front of the x squared, and I'll show you how to do that. I don't think we've done that much, if at all. And then the other big one that we're going to use today is difference of squares. So we're going to use these two.
Thanks.
Okay. So if we go back here, what's going to happen at first is sometimes you're going to have just numbers, just like if you have a fraction. And if you ever had 8/12, do you guys know if it was a harder set of numbers, do you guys know how to reduce a fraction on your graphing calculators?
No.
Okay, let me see. Sorry.
Those are my grades, Bob.
Did you get a good grade?
No, I have a terrible grade.
I haven't checked my grades ever since the term ended.
Smart.
Woo! They're still good.
My last.
Half decent.
Okay,
I got most of it.
so if we, let's say that you had a fraction that you needed to reduce, you can go, say it was 126/82, let's say, okay? You write it in, or you type it in here as a
What site showed
division
us
problem. And then what you do is you hit math, enter, enter, and it will reduce it for you, okay? So that is something you can do if you ever want to. Did everybody follow that?
Yeah.
Okay, so you just write it as a division problem and then go math, enter, enter, and it will reduce any fraction that you have, okay? Now, what we're going to be doing mostly today is doing rational expressions that each have a quadratic on top and bottom. Now, some kids would look at this and want to say, okay, I'm gonna just take out those x squareds because there's one on top and one on the bottom. You cannot do that. When things are added or subtracted together, when terms are added or subtracted together, the only way that you can get rid of something on top and bottom is if it's exactly the same.
It is
Okay.
exactly the same. It's x
If-
squared and x
Okay,
squared.
here, if you had 4x squared over 6x squared, you can reduce those. But once you have something added or subtracted to that, you cannot get rid of those x squareds. If something's added or subtracted to it, you can't. So what we have to do here then is we have to factor both of these. And when you factor both of these, then what you can do is see if one of your products that you factor into are identical, and then you can cross them out. And then what would be left is x minus 3 over x minus 5. But again, we can't get rid of those x's because there's something subtracted from both of them. Okay? So another thing that's going to happen today for these first couple of problems, don't let me forget to answer this. We have to say, for what conditions is this expression undefined? And I'll talk about that too. So the first thing we're going to try to do is simplify this as much as we can. Factor it as much as we can. That 5x I can't do anything with. Oh, you know what? They just reloaded my my smartboard today because I've been having problems. So now my inks are back to the other colors. That makes me sad. Okay, anyway, so we have to factor this right here, okay? So what we have to do, and some of you are good about not even using the box anymore, and I'll try to talk about that and get you guys to, you can use it, and I put it for every problem, but as you go through math, some of you will not use this every time. However, my son is in college, he still uses a box when he factors. So it just kind of depends. So if we look here, we have x squared goes here, the 3 goes here, 3 goes here, and then this 4 goes here. So what I'm doing is just factoring this right here. Okay? Now, let's say we don't want to use that method anymore. Let's just try to factor it without using the box, just because it's quicker. If you can't do it without the box, that's fine. But let me just show you what you can do. Since these both are plus, this is on your cheat sheet, both in the center. I can show you here. It's here on the one side, and it's also on the back of that cheat sheet. So you will have that all the time, okay? And if they're both plus, what this tells you is if both signs are plus, the signs in the parentheses are both plus, okay? Then, if this is x squared, you know that it's going to be x and x. And then, without really writing it in here, you can do that. But what you're going to do is try to find 2 factors of 3 that when you multiply them give you 3, but when you add them give you 4. What are they? 3 and 1. Now, do you guys get how you can check this too? Is this is 3x, right? This is 1x. If I add them together, it gives me 4x, okay? So that's a way that you can check them. So like most people, once they've factored for a while, they just kind of do it like that versus this, but it's completely up to you. If you're still wanting to do it this way, 3 times 1 gives us 3, 3 plus 1 gives us 4. So then I'd have a 3x and a 1x, and then I'd have an x and an x here, a 3 here, a 1 here, and so your factors would be x plus 3 and x plus 1, okay? I'm grading your test right now, and a few people got the factoring ones wrong. When they did this, they got the signs wrong. So if I was solving this like on the quiz, shouldn't x be a -3 and x be a -1? They went directly from here to the answer, and I don't know where they got it wrong, but instead of having a -3, they put a +3. And for here, instead of having a -1, they put a +1, okay? All right, so I got that top part factored. Now on the bottom, I have this x minus 9. And do you guys recognize this as anything?
Factor 0x. Just like think of 0x.
No, it's a type of factoring. Does anyone recognize this as one of the types of factoring?
Was it perfect square or perfect square trinomial?
No, but does anyone see by looking at this? You have 2 terms, so it has to be difference of squares. Do you remember how to do difference of squares? With difference of squares, this is what you get. You have 2 parentheses. One is plus and one is minus. If this is x squared, you get x and x. And if that's 9, do you remember what to put here and here? 3. And before I even started that, I should have talked about why this is difference of squares. This is difference of squares because your x is an even number. It can be 2, 4, 6, anything. This has to be a subtraction sign, and this has to be a perfect square. And your perfect squares are on the back of your cheat sheet. They're these numbers in red, okay? Any number times itself that gives you a number, that's a perfect square, okay? Now, I'm gonna do one part of this right away so I don't forget, but one of the parts that you have to do here is you have to look at the bottom or the denominator of your fraction, and you have to say, for what x values would this not work? Why? What can't you have on the bottom of a fraction? What number can't you have on the bottom?
0.
A 0. Okay, you cannot divide by 0. What would you get if you divided by 0? Undefined, and your calculator would say error. What x right here would give us 0? A 9, right? Just like when we were solving before, if this was x minus 9, doesn't your x equal the opposite of that? So x equals 9 cannot be an answer. What x would I have to exclude here? What would give me 0? Negative 3. Everybody get that? Just the opposite of this. And what x would give me a 0 here? 3. So this is part of our answer, okay? Now, once I have that done, I can go and start to cross out anything that's on the top and the bottom. So do you see how I have an x plus 3 and an x plus 3? Those cross out. Do you see anything else that's both on top and the bottom? No. Do you think I could cross out this x and this x? No. What if this was a 5x? Could I cross out that 5x and that 5x?
No.
Why not? Because it has a minus 9 with it. Okay, so now all you're going to do is write what's left on the top.
That's your answer.
And what's left on the bottom, and you leave it in factored form. Like this, and that's your answer. Now, one thing I want to point out, notice that I did with x's, I have to exclude for my answer before I cross things out. So I don't want to do all of it and then decide what x can't be equal to. Once I factor, that's when I say what x can't be, okay? All right, so let's look down at this one. And I have x squared minus 5x minus 24. That is trinomial factoring, okay? So let's go ahead and try to factor that. And if this is 2 negatives, you can look here, actually up here. If it's 2 negatives, what that tells us is one has to be plus and one has to be minus, okay? If it's x squared, that just tells me I get an x and an x. And now what you're going to do is we need, Mason, put your phone away. We need 2 numbers that multiply us to give a negative 24, that when we add together, they give us a negative 5. Does anyone know what that would be? Negative 8 and 3. So do you get that I put an 8 here and a 3 here? Everybody okay with that? And if you wanted to go back over here and do your, x squared negative 24, this would be negative 24, this would be negative 5, negative 8 times 3, you'd get negative 8x, you'd get 3x, x, negative 8, 3, and you have x minus 8, x plus 3. So there's nothing wrong with using that box if you still feel more comfortable with that. Now let's go to the bottom of this. Do you guys recognize this? It's 2 terms, and anytime today you have 2 terms, you're going to look for difference of squares. Is this difference of squares? Yes. It has a subtraction sign. This is an even power, and 64 is a perfect square. So I do my two parentheses, and I do x and x. Do you remember what the signs are? Plus and minus. And if that's 64, what two numbers multiply give you that? It's 8 and 8. Now can I cross anything out? X minus 8, and my answer would be x plus 3 over x plus 8. Now, I just realized I forgot something. And that is, before I cross things out, I didn't say what x cannot equal. What can't 8 equal here? -8 and 8, okay? So not all of the questions are going to ask that, this part, just the first couple, but that's what they want for that. If they don't say, like, the directions here were, under what conditions is this expression undefined? And that's when you factor the bottom and make sure the bottom can't equal 0, okay? All right, so let's go to this page. And now this one only asks us what values are undefined in this rational expression. When they ask that, you guys, we don't care about the top at all, okay? On the previous problem, it asked us to simplify it, so then we would go and factor the top and the bottom and try to simplify. This one is only asking us, for what values is this bottom going to be undefined, okay? So we're gonna only worry about the bottom, and I'm gonna try to factor this right here. Now notice it has 2 plus signs, and if it's 2 plus signs, you have plus and plus, okay? If this is x squared, we do x and x. Now, can you figure out two numbers that multiply to give you 8 and add up to give you 6? 4 and 2. So one of these is 4, one of those is 2. And now that's factored as much as it can be. Now, all they care about is, for what values of x would one of these be 0 on the bottom? So it's kind of like you're thinking, when would 4x equal 0? If you were to solve this, wouldn't you divide by 4? And what's 0 divided by anything? 0. So the way it works is, if you just have a single term with an x in it, it could be 12x, 15x, 15x squared even. If it's just a single term with an x can't be 0, okay? What can x not be for this one? And what about here? -2. And that's all we had to do for this one. Okay. Now let's look at this one. And this one we do actually have to simplify. But this one, if you notice, it doesn't say to state what values you have to exclude or what values would make the bottom undefined. It doesn't say that. So we just have to simplify. What do you guys recognize this top to be? Like, what would I have to do with this? Difference of squares. Yep. So you're going to do difference of squares. Difference of squares is always plus or minus. And in difference of squares, you have to have a minus sign, you have to have a square, and you have to have a perfect square for any numbers. So this is x and x. And then what numbers would I put? 2 and 2. Okay. Now this one's kind of nice because the bottom is already factored. So I'm just going to copy that down. But there is one more rule that I didn't talk about. Okay. If I had an x plus 2 on top and a 2 plus x on the bottom, are they the same?
Yeah.
Yes. Okay. So if you ever had an x plus 2 on top, x or 2 plus x on the bottom, you can cross them out. However, if you have an x minus 2 on top and a 2 minus x on the bottom, you can't cross those out. They're not the same thing. However, if you multiply one of them by a -1, then you can cross these out. And the reason is, if you do -1 times x minus 2 and you distribute that, you would get -x when you do this, and then -1 times a -2 is +2. If I wrote this with the 2 in front, wouldn't it be 2 minus x? Do you get that? So if you put a -1 in front of that, it is 2 minus x, okay? So what we can do then is we can cross those two out. All right, but that negative stays there. All right, so when I go back to this, one thing that you might do that you just get used to, if you have like x minus 2 on top and 2 minus x on the bottom, you can cross those out, and in front of that first term on the top, put a -1, okay? So now, what we are left with on the top is -1 times x plus 2, and on the bottom, we're left with x plus 1. Now, your book wants you to distribute the -1. And so what we would get then is -1 times x is -x, -1 times 2 is -2, and that is over x plus 1. And that's my answer. Do you get that? So if you ever have an x minus 2 and a 2 minus x, cross them out and just put a -1 in front. And then somewhere throughout the problem, you'll have to distribute that -1 across one of the terms on the top. All right, so let's look at B. What could I take out? Another type of factoring that we haven't talked about yet is what is in both those terms on the top that we can take out front? A z, right? And then if I looked at z times what gives us xz, don't I need an x? Minus z times what gives me 4z, I need a 4. Do you all understand that? I just took a z out of both terms. Now the bottom, I can't do anything with that z squared, and then I just have this 4 minus x, okay? Does anyone see anything we can simplify? Dan?
If you make the top, if you multiply by -1, then you
Yes.
take out the x minus.
Then these are gone. Do you suppose I could get rid of a z if I have 1 on top and 2 on the bottom? I can. So on this one, I have a -z on top. I have z squared on the bottom. You have 1 z on the top, 2 z's on the bottom, so you can take out one of them. And you get then 1 z would be gone off the top. And if I have 2 on the bottom and I take 1 away, I'd have just a z there. Do you guys get that? Okay. All right, now if we look at this, on the top here, does this look like difference of squares? This is a perfect square.
What the heck?
This is a perfect square, right? This is a subtraction key, and this is squared. So is that difference of squares? Yes, even though that 25 is in front, that's still difference of squares. So if I try to factor that, okay, with difference of square, you go plus or minus. Now that 25, you're basically taking the square root of it, and that's going to go here and here. What times what gives me 25? 5 times 5, okay? And then if that's v squared, do you get that the v's would be here? And it is important, if the v's are at the end, the v's have to be at the end of these parentheses also, okay? Now, this one you guys aren't going to love, because it has a number in front of the v squared, and we haven't done maybe any like this, I'm not sure if I did or not.
That's a problem.
It's not a problem, no, I promise, okay? So here's what we're gonna do. We're gonna put our two sets of parentheses, okay? It has minus, minus, okay, which means one's plus and one's minus. And as you're getting used to these, when they have that 3 in front, if I were you, I would use the box for a while, okay? So that 3b squared is gonna go here. The negative 10 goes here, just like before, but this is where it's different. The number that goes here is what you would get if you multiplied 3 times a negative 10. And 3 times a negative 10 is negative 30, okay? And then what goes here is still that middle term. The only thing I changed on this at all is this number is what you get when you go 3 times a negative 10, okay? Now this we do just like before. Can you guys think of two numbers that give you negative 30? One's going to be plus, one's going to be minus. That when I add them, I get a negative 13.
Negative 17.
Yep. Negative 15 times 2. Okay. So that means one of these is going to be negative 15b and one's going to be 2b. Okay. Now, one of these, the only way I can get 3b squared is one has to be 3b and one has to be b. And as you're getting used to this, you're not really going to know which one to put where, but you'll know if you made a mistake. Not really a mistake, you'd know if you put it in the wrong spot, because if I tried to figure out 3b times what gives me 2b, do you get that I'd have to have a fraction, right? Or 1.5, or not even that, 2/3 I would do. So I don't want to have a fraction, so what I'm going to do instead is put my 3 here and my b here. And now I can think of b times what gives me 2b, and that's 2, correct? And then what times 3b gives me negative 15b? Negative 5, okay? So now I have it factored. One of my things is b minus 5, and one of my things is 3b plus 2. Now, if we didn't have the box method, and I know some of you don't really like to do that, how we teach it when we don't have that is that we're just kind of doing trial and error. You would try factors of 10 here and here. You would try factors of 3b here and here. And you always just have to make sure when you multiply these two and when you multiply these two and you add them together, you get this. And did we? Is 2b plus a negative 15b negative 3b? It is. So some of you might go right to that, and some of you might want to keep on with this for a while. Okay? Now, we got it all factored. Now we just have to decide if we can cross anything out. Can I cross anything out? Yep, as long as I put a -1 out front, right? I can get rid of those. So on top I have -1 times 5 plus b, and on the bottom I have 3b plus 2. Now honestly, that's not the end of the world if you were to leave it like that, but your book is going to distribute this and get -5 minus b over 3b plus 2. And that's your answer. Okay? All right. We are going to do one more page, and then I'll be done for today, and then we're going to spend 2 days on it. Sound good? Guess what? Oh, my stupid smartboard. It loses stuff. Okay, go ahead. Sorry. I'm just
Why?
Yeah.
What is
Yeah,
that?
that last
What?
one is
Doesn't this look like a great, like, extra credit problem for a test?
Extra credit, all right.
But anyway, yes, to do this backside, if you look on the very back page, you have 6 things to factor.
And you have to divide and add them.
And if you were doing the box method, I put 6 of them here. So,
That doesn't look too
What in the friggin'
So, all right, so again, I lost everything here, so I just need to explain this to you. No, we will. Okay, so when you multiply and divide fractions, okay? What it basically is saying, like if you had 5x over 4 times 3 over 2x, okay? When you do this, you could try to simplify here first, or you could multiply across the top and multiply across the bottom and then simplify. It's up to you which way you want to do it. Do you guys think we could cross out these x's?
No.
Yeah.
Are they combined with a plus or a
No.
minus at all?
No.
Then you can. So these are gone, okay? That is, I can't really get rid of them. 5 times 3 is 15. 4 times 2 is 8. Is there a number that goes into both 15 and 8?
Oh.
No.
No. So that would be our answer, okay? Now, if they gave you division, like let's say they said 3x squared y over 7xy squared divided by 14y, and this is 18x, okay? Do you guys remember what you did in middle school, or not middle school, elementary school? When you learned how to divide fractions, you wrote it instead as a multiplication, and what did you do with the second one? You flipped it, right? So if you were writing this out of your book onto your page, you could flip it as you copy it down. Do you guys understand that? Like just make this times, put the 14y on top, and put the 18x on the bottom. Okay? Do you get it? I just changed this to times, and I changed these two.
You divided.
Yes. Everybody okay with that? Now, there's 2 different ways you could do this. Some people will choose to multiply across the top and multiply across the bottom and then simplify.
Simplify.
Okay.
first, it gets easier.
But do you guys see, does 3 go into 18?
Yeah, 6.
Doesn't 3 go into 3 once and 3 go into 18 6 times?
Yep.
Okay. How about 7 and 14?
Twice.
7 goes in here once and 7 goes into 14 twice. You could put ones by these if you wanted to, okay? I'm gonna leave my variables to simplify till the end, okay? So now if I kind of combine what I have on top for numbers, I really have 1 times 2, which is 2, okay? And then I have an x squared. And how many y's do I have? 2, okay? On the bottom, the 7 became a 1, the 18 became a 6, so I still just have 6 on the bottom. And then how many x's do I have? 2. And then I have 2 y's also. Do you guys get that? Okay. Now I just made this up, but don't my x's all cancel? And don't my y's all cancel? And then what happens with the 2 and the 6? 2 over 6 would reduce to 1/3. That would be your answer. If you guys take your AccuPlacer, is anyone taking your AccuPlacer tomorrow?
No, they haven't given us any information.
Still? Oh, yeah. Today's Tuesday, isn't it? Sorry. But you should have stuff like this on there. And I'm probably not going to get to the adding and subtracting until,
Oh, yeah.
but yeah. Okay, example 4, I want to show you what this should have, well, you guys probably have it, it's just,
6C over 5.
just is gone from mine.
Let's simplify first.
Okay, so simplify first.
Yes.
What can, and I usually just simplify my numbers, I leave my letters till the end. 5 and 15, can I simplify those? 5 becomes a 1, right? 15 becomes a 3. What goes into 6 and 8? 2. 2 goes in here how many times? 3. 2 goes in here how many times? 4. So let's just look at our numbers. Across the top, 3 times 3 is 9, right? How many C's do we have? How many D's? 2. 2, yep, okay. Then on the bottom, for our numbers, we have 1 times 4, which is 4. And we have a D and an A. Now, this is like a picky thing in math. This is not something I would take points off for. But if you ever have to write DA down, they always want you to put it in alphabetical order. So instead of doing DA, you're supposed to write AD. Not something I would take points off for. But 9 and 4, is there a number that goes into both of those? No. So 9 over 4. I have C squared. Do I have anything to cancel that? I don't. What if I have 2 D's on top and 1 D on the bottom?
1D on.
1 D on top, and then don't I still have that A on the bottom? And that is my answer then. Okay. Now if I look at B, and then we'll be done. We have 18xy cubed over 7a squared b squared divided by 12x squared y over 35a squared b. Okay? Now, when I go to do this, I am going to rewrite it because it's a division problem. If I was doing this out of the book, I'd probably flip it and change it to multiplication as I write it down. So 18xy to the third over 7a squared b squared. I'm going to change that to multiplication. And on top, I have 35a squared b. On the bottom, I have 12x squared y. Okay. Let's just look at our numbers. Does something go into both 18 and 12? The biggest number that goes into both? 6, right? 6 goes in here 3 times. 6 goes in here twice. What goes into 7 and 35? 7. 7 goes in here once. 7 goes in here 5 times. So on top, I have 3 times 5, which is 15. Really, truly, and again, not that this is wrong, but do you see how you have x's, y's, a's, and b's? You're really supposed to go a squared b x y cubed. Just put them in alphabetical order. But again, not a huge deal. On the bottom, 1 times 2 is 2. And then these are in alphabetical order, a squared, b squared, x squared, y. All right. Now, let's look at if we can cancel anything out. We have 15 over 2. That is reduced already, right? What if I have 2 a's on top and 2 a's on bottom? They're gone. What if I have 1 b on top and 2 b's on the bottom? A b on the bottom. Okay. What if I have 2 x's on the bottom, 1 on the top? 1 on the bottom. And what if I have 3 y's on top and 1 on the bottom? 2 on top. That's my answer. Do you get it? Okay, give me a second to come up with.
How did you get 7 and 12 factored down?
How did I get 18 and 12? 8, is that what you're talking about?
Oh, never mind. It was, never mind. Yep.
You got it? Okay, give me 1 second, guys, to figure out what I'm gonna give you for your assignment.
I don't need any more assignments.
Wait,
Ms.
does
Bob.
that go to diagonal? Oh, gotcha.
What is
I-
that?
No,
You have to memorize it?
no.
Oh, you don't like it to go like this?
Yeah, yeah. You can read off of it if you make it look. You have it.
What is it about?
Actually,
Nolan, where's Nolan? You should go and ask Teresa if she would come down here. She was the one helping
Give
me.
me the speech.
all right, I'll be back, but
No, give me the
No, you,
speech.
oh, wait, no,
Yeah.
you should ask Cody.
I need a paper to speak. What?
You should ask Cody.
Alright.
What
Ah!
I page my speech around here.
Yeah, but you gotta know your speech.
Guys, I just lost my notes.
So know your speech.
I didn't remember that.
That's your problem.
Peter, stand up in the front and give us a speech.
Yeah.
Yeah. No, here, you.
I said, Peter.
Yeah.
What? What does that have to do with me?
You're holding,
Yeah, you got
you're holding a speech.
So go up there.
I
So if you're holding a speech, it means it's your speech.
Zoom back right there.
That looks like Peter and me.
I said, Peter. Somebody give the speech, I wanna hear this.
Oh, no, how good I did. I'm gonna get like a 10 on a 15.
Can I go to the bathroom? I actually am, promise.
Yes, you can.
Oh.
Here.
Is that for volleyball or
No, I
just
just go to the, I just have a
Right here.
membership.
at Snap Fitness?
No, there's one in Sartell, that's like bigger than the one in St. Joe.
What do you do? What is it called?
Stay fit.
Alabama is back at number 2.
Okay, this is not gonna be your assignment, so don't copy yet, because I have to take off what I didn't teach.
Mama.
Can I go get a drink of water?
You can.
Who's at 5? Yeah. Who's at 5?
Was it Dewey?
Was that, anybody have a guess at who was at 5 in
I wish we did.
the AP top 5? Why was Georgia be at 5?
Can I go fill in my laptop?
You can.
Right now.
Right now?
Just fresh.
Who's number 5?
Yep.
Ms. Button, I have so much homework to do. I don't need another assignment.
Taylor.
I know she said she changed it, but I'm
The
getting.
Ohio State University,
I was about to say.
which they moved on from. Oklahoma State.
Oh, where's Minnesota?
No, she's got.
What was it, top 10?
No, it said your league had.
25.
25.
Oh, did it?
It said you're playing.
No, it's not. Oh, wait.
Yeah, you slash. Your slash ball. So you have to.
No, not.
It said. So you're sitting.
Who did it?
Yeah.
No, you lied.
No, the new one.
I just seen it, bro.
The new one that just came out.
Yeah.
Alright,
Are you gonna do it?
Well,
Oh, yeah, I'm gonna read it. I'll read it for the class. I want to be sitting Brandon would.
No.
Hey, who wants to hear, own
Brandon's
speech?
sick too.
Well, you're gonna read
Vaccines. They are at the height of controversy today. That's, oh my God.
Okay,
And
stop.
with it is freedom.
Let me cut the corner out.
How does it?
Yes, and
Sorry.
slash his face.
And with it is freedom and medical choice.
Yeah.
Everyone has had a vaccine at some point in their life. but nobody
Okay,
should be
this is
forced
your
to get one.
assignment.
From the beginning, the United States built off the foundation of freedom and personal rights, including religion, voting, and medical choice.
Guess
The
what?
Constitution even states multiple rights that citizens acquire just from living in this country. Seeing that a vaccine
Do you know that you were being videotaped?